So what about compound inequalities that are joined by the word or? So we've dealt with and that was that overlapping region. Or is if at least one of the inequalities is true. So for example, we got x is less than -5 or x is greater than 0. So if I graphed x is less than -5, that would be an open circle at -5, shade off to the left. Now the second inequality says x is greater than 0. So it would be an open circle at 0, shaded off to the right. Now, if I were to graph these together, x is less than -5 or x is greater than 0, then it would be an open circle at -5 shaded off to the left, open circle at 0 shaded off to the right. All right? At least one of them must be true. There's no overlapping region like when we were dealing with and. So ors face away from each other. They go away from each other. All right, and there's no fancy way to kind of sandwich these together like we did with and, where the x was between the two numbers. All right, because x isn't between the two numbers. The solution region isn't that overlapping region. The solutions face away from each other. Okay, so let's look at solving and graphing an or compound inequality. So in this first one, you have 4x plus 3 is less than 11, or 3x minus 4 is greater than or equal to 8. So if I solve this first inequality, subtract 3 from both sides, I'll get 4x is less than 8. Divide by 4, I'll get x is less than 2. So it's an open circle at 2, shaded off to the left. And then for this second inequality, I would add 4 to both sides. 3x greater than or equal to 12. So x is greater than or equal to 4. There'd be a closed circle at 4, shaded off to the right. So I'm going to go back to this. I'm just going to make it a little bit more obvious that that purple one's going off to the left. So my solution is that x is less than 2 or x is greater than or equal to 4. So any numbers that satisfy either of those inequalities is a solution to this compound inequality. And then last example, number 2. We got -3x plus 1 is greater than or equal to 4, or 2x minus 5 is greater than 7. So looking at this first one, subtract 1, we get -3x is greater than or equal to 3. Divide by -3, so we're dividing by a negative, which means we have to remember to flip the sign. So we get x is less than or equal to -1. All right, now if I solve this last one, add 5 to both sides, 2x is greater than 12, so x is greater than 6. So if I were to graph these, the orange one, x is less than or equal to -1, closed circle at -1, shading off to the left. And if x is greater than 6, open circle at 6, shading off to the right. I'm just going to throw the word or in between these two and box it. And we are good to go. All right. So that is how you deal with an or inequality. Those graphs are going to face away from each other. All right. So we got a you try now here. 2 of them. The first one is an and. Second one is an or. Practice solving those, getting your final answer, and then graphing them. We will go over those in person when I see you. All right. So good practice. Make sure you reference these videos. It's the same steps, it's just you're solving multiple inequalities right now and graphing them on the same number line. So practice those you try nows. Let me know if you have any questions. Have a good one.